a stone is thrown into the still pond, right? Then as you can expect, the circular ripple is just like getting bigger and bigger and bigger, just moving up, right, from the point like which the stone was thrown, right? So that is the basic understanding about this problem, okay? So whenever you have this kind of problem, read carefully. That is always first step, okay? The second step is like write the given information into mathematics, okay, clearly. That is second step, okay? Then we can take it, okay? As I told you, maybe like in this problem, we're gonna have like two variable. Then both of them is like it is depend on the variable t, which is parameter, right? And then we can easily find the bridge equation between x and y. That's it, right? So here we go. The stone is thrown into the still pond, then circular ripple moves out, right? So they are talking about, okay, look at that, the first information. The radius of the disturbed region increased at the rate of 3 feet per second, right? They are talking about the radius of the ripple. Basically, we assume the circular ripple is perfect circle, okay? Does it make sense? So, okay, whenever you have this kind of problem, I strongly recommend draw the figure. Let's just, okay? At some instant, then you will have like circle, then they are talking about radius. So let's say radius is r, okay? Then they gave you dr dt is equal to 3 feet per second, okay? But keep that in mind. Since your circular ripple is getting bigger and bigger and bigger, your rate of change of r in terms of with respect to t must be positive, right? And what about second one? Find the rate at which the area of the disturbed region is increasing, okay? They would like to talk about the rate of change of area, okay? Let's say area is capital A, okay? Then the question is what? dA dt. This is the question. When the farthest ripple is 20 feet from the place at which the rock struck the pond, right? Which means that when the radius are equal to 20, right? So I can say your r is 20 feet, okay? That's it, okay? So look at that. We have two variables, r and a, and one side the rate of change is given, and the other side is question, okay? We have like, the instant, which is given information, right? Then we need to find the bridge equation between r and a. What kind of bridge equation can I use? Like relation between a and r. For the circle, perfect circle, it is the area of the circle, right? Here we go. So now let me write the bridge equation, okay? A is equal to pi r squared. Does it make sense? The perfect setting, okay? We've done the perfect setting. Now we have to solve it, okay? How? We will take the derivative with respect to t, right? Here we go. d dt, right? Then a prime, yes, dA dt, right? And then pi is just coefficient, okay? It is not the product one. Pi is just in front of r squared. Then pi is there. Then we have to take care of r squared prime, okay? Keep that in mind. Pi is number, okay? R squared prime is 2r. And then don't forget you have to multiply dr dt, okay? So let me rewrite here, okay? Since we don't have enough space here, okay? dA dt is equal to 2 pi r dr dt. Now let me double check, like, we have all the information, okay? Here we go. dA dt is the question, right? And r is given 20, right? And dr dt, there we go, it is given, right? So now, like the last step is just plugging in all the information, okay? Here we go. dA dt is equal to 2 pi, r is 20 feet, and then dr dt is 3 feet per second, right? So the rate of change of the area is equal to 120 pi feet squared per second. This is the answer, okay?